permutation combination. This chapter is fundamentally about learning how to count systematically. Also, it is about learning how to figure out the count of something, how many things there are, without having to manually count them one by one. So, so if I were to tell you that, let's say there's a competition where teams compete and each team has 4 people, A, B, C, D in this particular team, and round 5, let's say, has is such that 2 people from the 4 have to go and stand at one place and compete for that particular round. So at the beginning of round 5, you have to select 2 people from the 4 people to represent the team for round 5. And how can you do this? You would tell me, okay, let's take them one by one. AB can be a team, AC can be a team, AD can be a team, BC, BD, CD. There are no other combinations possible. So you'll say there are 6 ways of selecting a team of 2 from this team of 4 people. That's all well and good. This is a very simple, small enough example where you can list them out one by one. But what if you can't? What if this competition has a team of 10 people and you have to select 5 people for this particular round? Now you see that you cannot actually list them out one by one. I mean, you might want to try, or you might not, but it's very painful, right? Let's say you have A, B, C, D, E, F, G, H, I, J. E, F, G, H, I, J. A, B, C, D is a team. A, B, C, D, F is a team. This is going to take a long time, and we are not interested in actually listing out everything. We just need to see how many there are. So there should be a logical approach to getting the full count, counting systematically and getting the correct logical approach to getting the count. How many there are? We're not interested in seeing each one of them one by one. We're only interested in seeing how many there are. That is where this chapter comes in. So that's the first thing. And there are tools, there are mathematical functions that will help us do this. So as far as this particular example was concerned, we are selecting 2 from 4, and for this we use the combination function. We will discuss them in detail as we go ahead, but I just want to quickly make the distinction between combination and permutation. Now on the other hand, let's say forget round 5, we created a team of 4 people. We have to appoint one person as the captain and another as the vice captain. How many ways can this be done, right? Now let's say that my convention is, if I'm writing AB, then that means A is the captain and B is the vice captain. In which case you will probably agree with me if I say that BA is different from AB, because in the second one that I've written, B is the captain and A is the vice captain. So you see that this is to be counted and this is to be counted as well. And so if that were the case, how many ways can you decide the cap and the vice captain for this team of 4? Just like before, AB, AC, AD, BC, BD and CD, but you also have BA, CA, DA, CB, DB and DC. Notice that the ones that on the right that I've written is just flipping the captain and the vice captain from the one on the left. But the thing is, there are 12 ways of determining captain and vice captain. There are 6 ways of selecting 2 people for our round 5, which requires only 2 people. So when the order matters, when BA has to be counted separately after counting AB, that is when we use the permutation function. We are counting the number of ways of arranging 2 items from 4 items. AB is one particular order, BA is another order, even though the selection is same. So for arrangement we use the permutation function, and for selection we use the combination function. We'll talk about more about what these functions are, how they are applied, and what is the logic behind all of this in the next video. As I said, when you want to do selection, you use the combination function, and how we normally denote it is NCR, with N being a superscript on the left side and CR being a subscript. NCR represents the number of ways of selecting R items from N items. So in that previous video, selecting the two people who represent the team in round 5 would be done using the combination function, and that would then be 4C2. And the formula is NCR is n factorial by n minus r factorial r factorial. So in this particular case, 4C2 is going to be 4 factorial by 4 minus 2 is 2, so 2 factorial, 2 factorial. This 4 factorial is going to be 4, 3, 2, 1 product, and 2, 1, 2, 1. This will cut, 4 and 2 will cut, you get a 2. There are 6 ways, and we already listed and verified that it is 6. There are 6 ways of selecting 2 people from 4 people. So this is the formula for selection using the combination function. For finding the number of arrangements, we use the permutation function, which is written as NPR, which is the number of ways of selecting and arranging R items, arranging R items from N items. And the NPR formula is n factorial by n minus r factorial. So in that previous example that we mentioned, you had to select the captain and the vice captain, and I was choosing to list them with the captain being listed first and the vice captain being listed second. So A, B would mean that A is the captain, B is the vice captain, but BA would mean that B is the captain, A is the vice captain. So that was how I was going to list them. So the order also matters. So it's essentially a question of arranging 2 items from 4 items. And for that you have to do 4p2, which is 4 factorial divided by 2 factorial, which is 4, 3, 2, 1 divided by 2, 1. 2, 1, 2, 1 will cancel, and you'll get 4 and 3, 12. There are 12 ways of selecting and arranging 2 items taken from 4 items.